Okay, hey guys, let's take a look at another functional equation. So this question is like find all function f from integer to integer for which we have f of 0 equals to 1 and f of n is equal to f of n plus 2 equals n. For f originally is a natural number n, but I think there may be a typo mistake. So I modify it into for every integer n. So first of all, we would like to make use of the expression which is f of n is equal to n. Actually, this dot means this expression. So you can write the dot as a bracket, but if you have several layers of a composite function, that may be difficult to figure. So this is another notation, but nothing special. So actually, f of n equals to n implies that f is injective. Injective. So what does injective mean? It means that if f of m is equal to f of n, then m is equal to n. Or you can express it as if m is not equal to n, then f of m is not equal to f of n. So this one is a p implies q, and this is not q implies not p. So they're actually the same. So we can prove this by contradiction. So proof by contradiction. So we can assume f of a is equal to f of b, where a is not equal to b. So we can apply f on both sides. F of a is equal to f of b. However, this is equal to a, this is equal to b, which means that a is equal to b. So we have a contradiction, which means that we successfully prove that f is injective. So f is injective means f inverse can be defined. So we can make use of the original expression f of n is equal to f of this case we can use a bracket. So f of n plus 2 like this. So we can apply f inverse on both sides. So in this case, we can cancel this one and this one. Cancel this one and this one. So we come up with the left-hand side will be f of n is equal to f of n plus 2 plus 2. So this is very useful for us, and also we would like to make use of f of 0 equals to 1. f of 0 equals to 1. And by the way, we can also use f of n equals to n and plug in n equals to 0. So it is equal to 0. However, this one we can substitute f of 0 equals to 1, which means that f of 1 is equal to 0. So we also have f of 1 is equal to 0. So we can make use of this one, and we can slightly rearrange it as f of n plus 2 is equal to f of n minus 2. And then we can have f of 0 equals to 1. So we can have f of 2 is equal to f of 0 minus 2, which is 1 minus 2, just 1 minus 2. So it is a negative 1. And then f of 4 is equal to minus 1 minus 2. So it is minus 3. And then etc. etc. So that we can come up with f of 2n equals to minus 2n plus 1. Actually, you can prove it by induction for a more rigorous proof, but actually I think it should be good enough, or I think it's very trivial to prove this. So next, we can make use of f of 1 is equal to 0, so that we can have f of 3 equals to 0 minus 2, which is negative 2. So f of 5 is equal to minus 2 minus 2, so minus 4. So etc. etc. So finally we can have f of 2n plus 1 is equal to minus 2n, or you can write it as minus 2n plus 1 plus 1. So next we can have this one, f of n is equal to f of n plus 2 plus 2. Still, we make use of f of 0 equals to 1 and f of 1 is equal to 0. So that f of minus 2 is equal to f of 0 plus 2, which is 3. And f of minus 4 is equal to 3 plus 2, which is 5, etc. etc. So finally we can have f of minus 2n is equal to 2n plus 1. Or you can have a minus 2n plus 1. So we can make use of f of 1 is equal to 0, so that we can have f of minus 1 is equal to 0 plus 2, which is 2. And then f of minus 3 is equal to 2 plus 2, which is 4, etc. etc. And finally we can have f of minus 2n plus 1 is equal to 2n. 2n plus 2, 2n plus 2. Yeah. So actually we can have minus 2n plus 1 no, not this way. So it should be like this. Like this. Should be like this. 2n plus 1 plus 1. So this should be f of 2 minus 2n plus 1 equals to 2n. Yes. Yeah, f of minus 2n plus 1 equals 2n. So we can rewrite it as minus 2n plus 1 and then plus 1. So by summarizing this 4 expression, so we can conclude that f of n is equal to minus n plus 1, because you can see here 2n minus 2n plus 1, 2n plus 1 minus 2n plus 1 plus 1, minus 2n minus 2n plus 1, minus 2n plus f of minus 2n plus 1, minus 2n plus 1. We still have a minus sign here. So minus 2n plus 1 plus 1. So finally, we can just check whether this fits f of 0 equals to 1. So this is good. And then we still need to check whether f of n equals to f of n plus 2 equals to equals to n. So f of n is f of minus n plus 1 equals to minus n plus 1, which is n. So this is good for this one and this one. So and next we check f of n plus 2 is f of minus n plus 2 plus 1 plus 2. So we have f of minus n plus 1. So this is actually this one. So equals n. So yeah. So here we conclude that f of n is equal to minus n plus 1 is the solution, and this is the end of this video.